look attractive to the surrounding nodes, okay, with respect to the underlying routing metric. You can see an example here. On the left, you can see the topology of the network before the attack. Here, so you see that all the nodes have chosen their parents, okay, and they have constructed the path towards the base station. Okay. Now, once the attacker started transmitting over here, you can see specially crafted messages that target the underlying routing protocol. Eventually, what you see here is that all nodes forward the messages to the attacking node. Okay. So again, the attacker has access to all of the messages, but in that case, since you are their legitimate parent, okay, you are the node that they are supposed to forward their messages. Even in the case of that we are using encryption techniques or cryptographic algorithms, they send you the encrypted messages, but after a while, what they use in sensor networks like hash chain and key chains, they will send you the key. Okay? Because you are their parent, and at some point you have to forward the messages, and you have to do the data validation, so they send you the key. Okay. Now, this attack was one of the first that was introduced in sensor networks. Okay. But in order to better understand how this works, we first have to talk a little about the routing layer model. Okay, so the routing protocols that are used in sensor networks are the same as in all other wireless networks. Okay, they are used for constructing communication path from all of the nodes towards the base station. Now, in sensor networks, there appears to be a great diversity in these routing protocols. Okay, but most of the existing ones, and actually I don't think that this will change in the near future, use link quality calculations as the routing cost metric. Okay, so what they do is the nodes choose as their parent, their immediate parent, where they forward their message that wants to reach the destination, to the node with the best link quality. Okay, and in that way, they build the routing tree towards the base station. Now, here I have put the two examples. These are the two most widely used routing protocols in sensor networks at these days. Even in very heavy network applications, okay, the smart home and smart cities, these are the protocols that they are using. So we have the mint route and the multi-hop LQI. The first one, the mint route, uses link quality estimates, again, as the routing cost metric. So what it does, okay, these calculations are based on the packet error rate. Okay. So the nodes periodically transmit a specific message called route update, okay, and all of their neighbors that over here, this transmission of the route updates, okay, they estimate the link quality based on the packet loss of these route updates. Okay. So the route updates have sequence number. Okay, so by starting the routing protocol, you have packet sequence number 1, 2, 3. If you lose 5, 6, 7, then they have created the functions that they have embedded inside the node. Okay, and you can find an estimation of the link quality. Obviously, as you can understand, okay, this is not a very accurate estimation, okay, because in sensor networks, especially in sensor networks, which are really, they don't have very strong antennas, okay, so you don't have very good link qualities. Now, also, each one of the nodes maintains a neighborhood table, okay, inside its memory that contains all of the IDs of its neighboring nodes along with the corresponding link qualities. So every time it senses that something changes inside this table, but it has to be something like a really big change, okay, like their parent died, so I have to delete it from the neighborhood table, or I see that my current parent link quality is really bad, so I have better link quality inside my neighborhood table. So this triggers the parent changing mechanism in order to actually choose your parent. Now, the multi-hop LQI routing protocol, again, operates in a similar way, but it considers that it has a better indicator for the routing as the routing cost metric. What is the difference is that the link quality estimation, calculation actually, is based on their own hardware that they have these sensor nodes. Okay. So actually this, the T-Mode Sky has this kind of hardware. So what they do, again, the nodes periodically transmit a message called beacon. So upon reception, all of the other neighboring nodes pass this message to this hardware. Okay, again, they have a function, and they extract the link quality. Now, the link quality is passed to another function that from this they calculate the cost of the path. Obviously, okay, the relation between the cost and the link quality, okay, is inversely proportional. Okay. If the link quality is better, then the path cost will be small. The minimum path cost that you can find in such protocol is the number 15. The important thing about the routing protocols is that all of them, they are all designed having stability in mind. Okay, meaning that once they have created the routing tree towards the base station, okay, they want to stick to it. They don't want to have many changes inside this routing tree. Why this is done? First of all, because whenever you trigger your parent changing mechanism, okay, this costs energy. And energy is really important in sensor networks. And also, if you make a lot of changes, okay, this may lead to routing cycles. Okay, because when you choose your parent, actually you don't know if this has a path to the base station. Okay, so this may lead to a cycle. So they have created, obviously, algorithms for avoiding this, not avoiding, they let them happen, but for deleting these cycles. But this is really costly. So they don't want to have such routing cycles. That's why, in order to have a change inside this routing tree, we might have two reasons. First of all is that your current parent died. For some reason, he doesn't have any energy, I don't know why, he died. So you have to change, you have to choose another parent. The other reason is that if you find in your neighborhood table another neighboring node, okay, that its link quality is 70% better than the one that your current parent has. Okay, so as you can understand, it must be really better than the current one in order to change your parent. Okay, so this does the sinkhole attack more difficult for the attacker. Okay, so now let's describe the most known ways that an attacker can launch a sinkhole in a sensor network. Now, the first strategy is really simple, and actually it's pretty idiotic, so that's why we have not implemented it in the attack tool, because it's really easy to be detected if the sensor network has any kind of defense mechanisms or security protocol, even the simplest one. So what an attacker can do is actually, its goal is to advertise a really high link quality for itself. Okay, so it sends fake messages, fake route updates, okay, advertising the highest link quality between itself and all of its neighboring nodes. Okay, the highest link quality is 255. But as we said, this may not be enough to trigger the parent changing mechanism to all of the other neighboring nodes. Because even if the attacker transmits a message advertising a link quality of 255, if their neighboring nodes, let's say, have a parent with link quality 170, okay, I don't think this is 7%, so they will not trigger the parent changing mechanism. So what they have to do, okay, they have to make the other nodes, the current parent, all of the current parents, okay, to make them look bad, okay, to have poor link quality. That's why they impersonate these nodes, okay, since they are considered as part of the network. Okay. Obviously, as all of the other neighboring nodes, they receive the route updates of all of the neighborhood. So they know what are the parents of each one of the nodes and what are the link qualities. So the attacker can impersonate each one of the parents inside the neighborhood, okay, and advertise a really bad link quality for itself and with its children. As you can understand, this can be used only for routing protocols that have as the routing cost metric link quality estimates, okay, not calculation like the mote that have the hardware, but estimates that, as we said, with the mint route. Because that's why this is what the attacker uses here, take advantage of, because it's an estimation, and actually you can convince the other node that this is my estimation. Okay, that's why they impersonate and they can send fake link qualities. But it's easy to detect, as we said, because since the node does something that is not legitimate, that's impersonation, okay, he can be easily detected by all neighboring nodes. Okay, especially if they have a protocol that has the nodes, makes the nodes cooperate each other in order to identify who is the impersonator, okay, then they will caught him for sure. Now the second strategy, again this is simple, and in order not to be detected, the attacker, it requires by the attacker to have a really strong antenna. Okay, so what it does, it advertises, it transmits a beacon message with the minimum cost towards the base station. Okay, so the minimum cost is 15. So what it says is that I am only one hop away from the base station. Okay, I have the minimum path cost, so all of you send the message to me in order to forward them to the base station. So he can send, again, fake messages, even if it is not the actual